Hello and welcome back. We're continuing our discussion about Git by discussing one version of a GitLab workflow that teams may choose to use when it comes to things like writing the code, branching, your merge requests, that's what MRs is, and potentially code reviews, or at least I hope so. And this is our second installment in the week 3 videos. So we had sort of started this conversation off by just being introduced to this idea of Git and some of the core commands and concepts surrounding Git. And now we're going to dig just a little bit deeper. So in this class, the way that we actually use GitLab is that each team will have its own GitLab repository within our group. So we have like a winter 2026 group. And all team members are going to have the same shared access and collaboration rights within your team's repository. If you go and you check out the project overview documents, it will tell you how to name your GitLab repository. Make sure you're doing everything sort of above board. You'll also notice that you will be unable to directly push to main, and that is on purpose. We're really trying to instill this appropriate way of moving through code. If we make a mistake, not having direct main access can be really, really annoying and tricky. It becomes a really big fight. I hope you don't have to experience what a big fight it can be when I make it so that you can't force push to main, but some of you may end up with that experience, so we'll see what happens. Basically, not being able to force push to main means that all your changes will have to go through this merge request process. You have to click buttons and make a merge request. There'll be some activities that you get to sort of do to learn how to do this. And this basically will help us ensure that code is actually getting reviewed before it gets merged in. Now, if you actually use code reviews, it's up to you. There's no way to actually stop you from just ignoring the code review, approving your merge request, and closing everything off, combining it into main, and being done. But I'm strongly encouraging you by forcing you down this path to actually utilize the code reviews and the merge request code reviews for what they are, which could be very, very helpful. This will encourage you to have clean history. It'll be obvious in what direction your code is going, and it will also encourage, hopefully, teamwork so that all of you see all parts of the code. Because when you do a merge or a merge request, you say, hey, I want to merge this into main, your teammates will go and look at your code. So it will hopefully encourage everybody to sort of be on the same page within the project. This promotes accountability. It means you can't just sneak code in. You can't just be like, oh crap, I forgot to write in some things. I'll just really quick, whoops, I just did something. Really quick, type something in and hope for the best, right? It will force your teammates to be notified when you're making changes. It helps ensure that your teammates know that changes have been made to files, so they may need to make a pull request and pull down the changes that you've made. So this sort of idea of increasing our accountability is really important. It will also hopefully help us catch bugs early. If somebody tries to commit code that has a bunch of if statements or whatever in it, and maybe you're missing cases, it is encouraging your whole team to look at your code. So maybe they will catch some of the edge cases that your code might be missing. And that's always really nice to catch early rather than, your instructor, myself, whomever it is, or a grader going in, trying out your project, typing in something and breaking it, right? Still might happen, but maybe we can catch some of those in the code stage instead of in the demo stage. And then lastly, of course, this does mimic professional team workflows. So team workflows would never allow anybody just to directly push into main. We don't have any of that business going on. Instead, there is this idea that when you're done working on a piece of code, you submit it for code review. So people are going to look at it. They're going to give you feedback. They're going to tell you what needs to change. A friend of mine used to work for Google, and their sort of anecdotal story about this is their very first code review that they submitted went through 23 rounds of changes. So that doesn't mean 23 comments. That means it was put up, and the team commented a bunch. And they went back and they made the changes requested from their teammates and said, okay, it's ready for you to look at again. And their team came back with more changes again. And that process occurred 23 times before it got merged in. Now, that won't happen in this class. We don't have that kind of time. It's not the real world. But this idea of all hands looking at pieces of code, all eyes all eyes looking at it, all brains thinking about the piece of code, it allows us to keep catching things and sort of produce better code at the end of the day. All right, so there are lots of different strategies when it comes to creating your own branch, doing your work, and bringing it back into main. Not all teams approach this the same. What I have found over the years is one that seems to work the best, and that's the one I'm actually going to be going through here. That being said, there's no requirement that you use this one. There are some required readings, there's the internet. You're welcome to go and do some research and find something that might work best for you and your group. Maybe somebody in your group did something different on a work term and that's what they want to use. It can be a discussion. There's no one right or one wrong way of doing it. I just found that this one, given the project scope, often works well. But it's totally up to you. In your project, you will be asked to sort of describe your branching strategy. So if you pick this one, you'll have a really good handle on it because I'm going through it with you. And if you pick a different one, you can explain it in your description of your branching strategy. It's totally okay. So the way it will work is this idea of a feature branch workflow. So every time you make a new feature, or a bug fix, you branch off of main. So you make a brand new branch. And when you're done, you make a merge request. You open a merge request. After the merge request has been reviewed, you merge it into main. So there's no committing to main. You're merging it into main. And then you may also have some extra branches, such as a dev stage or a dev branch or a staging branch, but you may not need those for this project. But some teams still do like to have these other areas where they can, if it breaks, it's not the one that you're submitting for marks, right? Because you're submitting, the grading happens on the main line. So if your main line is broken, you're going to get a really low mark. So it's nice to have sort of a development branch that you merge into. And then once you feel like you're good with what it looks like in development, then you merge that back into main. There's some options. Same as everything, document your decision-making process, right? So when it comes to branch naming, I recommend, because GitLab is going to give you issue numbers, that you use the following format here. We have issue dash whatever, and then a short description, probably very similar to the title of the ticket, of the issue. So when you have an issue number from Git, let's say you made an issue 42, something is going on with the login. When somebody goes to fix that bug, they would make a branch called issue-42-login bug, and then we know that this branch will be connected to issue 42 in Git. So having that sort of connection is really nice for communication and for cleanliness. It's really up to you how you want to name things. Just document it and actually use it. So you want to have somewhere that you can point to. If a group member says, I can't remember what did we decide on, you want to have it documented somewhere for them to look at. I'm also going to strongly discourage naming branches after yourselves. I see that a lot. I see people who make like a Lauren branch and then they do all their work in there and merge it in. And then they've basically created this branch that's living forever. The thing with branches is that they're not supposed to live forever. They're supposed to live for a very small amount of time. You work on something, you merge in, and you delete that branch. Do not keep it. The next time you need a branch, you make a new one. So if you name it after yourself, people get mighty attached to those ones. And they let them live for a really long time, and that's how things get messy quickly. Because changes that you made in there that you never intended to commit somehow accidentally make their way in, or changes that are for later and make their way through the pipeline. And you just want to be careful of that. So don't pick your own name as a branch. Pick something that you're okay with killing off quickly. Okay. So once your code is done and you push up your merge request, you push up your code and you do a request for a merge. What do we do here, right? So we talked a little bit about why we're going to use them. Teammates can catch bugs or suggest improvements. We have this idea of traceability. We can link code changes here to specific issues or tasks. So if more than one thing does happen to get fixed in a merge request, which we hope doesn't happen, especially if we name them according to a specific issue, but if a few things do happen to get changed for some reason, we can actually go through and make some links and make sure we know what's supposed to be considered done and what tickets might exist, what issues might exist that this is fixing, and we can close those. We have this idea of quality control. We can make sure that the code is tested and approved before merging, and we have our team knowledge transfer, right? Everybody on our team should be able to understand everything that's going on in our projects. You should all be able to describe your project. It's important to remember that when you submit your code, like for marks to your instructor, you are a group. So you can't come to your instructor and say, oh yeah, I see that, this file has a bunch of variables and they're all named A through Z, 26 variables, A through Z, but I didn't write that. I didn't write that bad code. That code is really smelly. All those variable names are terrible, but it's not my problem because I didn't write it. Because it is your problem, right? It is, because you're a group. So that idea of quality control doesn't just mean like in terms of functionality, but it also means in terms of standards. You as a group set standards for your project, how you want files named, different variable names, what security checks might need to happen in places, whatever it might be. And so then as a team, when new code comes in, you should all have an opportunity to make sure you're meeting those standards. Because once it enters your main and somebody goes in to grade it, it is all of your problem. So it's really important that you all sort of have eyes on all the code, because pointing fingers doesn't really help anybody. When you create your merge request, you're sort of given an opportunity to enter a message associated with it. You should make sure that you include a clear description of what your branch does. This often is just sort of a culmination of your commit messages, but sometimes we get a little bit messy or lazy with our commit messages, and it's nice to sort of be able to say, these are the things that I accomplished in this branch that I'm trying to merge. You should be referencing issues, right? If you put hashtag Octothorpe, whatever you want to call it, #, and then the issue number, it will auto-link. It will turn it into a URL, and then that way somebody could click it and go and see the issue that you're talking about, that you're saying that you're solving. This allows them to ensure that you're actually solving the problem that you say you're solving, right? If they can go and find the issue that you are saying that you're working on. You should also include some test notes. So if you're fixing bugs, you should be able to say how to reproduce the error in dev right now, and it will also tell them how to check to make sure your code actually works. They can pull your branch down, and they can actually verify that your code is doing what you say it does. If you also include test notes, like these are the situations in which I tested my code and that I know it works, it allows somebody else at a quick glance to look and read and say, oh, but did you consider this boundary case, or does your code handle this edge case really well? So having those testing notes really helps sort of move the process along quickly without compromising on quality or value. When it comes to actually doing the code review, so we've talked a lot sort of about what it looks like to be the person who made the code. You're the author of the code and you're the one who wants to merge it into main. But the rest of the team has a job here as well, right? They're going to review your merge request. This is a tricky thing to do. It is a skill that's learned, and if you have, a team of individuals who are submitting massive merge requests, it can be arduous and it can be overwhelming. So start with a really high-level overview. Read the merge request description. Look at the linked issues. See what the labels are. You need to make sure you understand the context of the code you're about to read. Once you've, I don't know what that is. I hope that just goes away. There we go. Once you've done your high-level overview, you're going to review the diff between the two files very carefully. So when you're being shown a merge request, one side of your screen will show what currently exists in a file, and then the other side of the screen shows the changes that are coming in. In green, it will show additions. In red, it shows deletions. If lines are being removed and stuff like that. So we can sort of look at the whole thing and get a sense of just how much has changed to allow us to better understand what next. Like, what next do we have to focus on? Then we can read line by line. We can look for the correctness of the code and the edge cases in testing. We can look at the standards and the style of it, right? Like, there's so many different pieces that we can look at, including maybe different team members looking for different things. If somebody's has a good eye for edge cases, maybe they're in charge of looking at the code review for edge cases, and somebody else is in charge of looking at the code style and maintaining the standards of the code base, right? You can assign each other roles to help make this an easier process. If you find things that are wrong, you can leave comments on specific lines. So you basically click Start a Review, And then you start leaving your comments on each line, and then you can end your review, and somebody will get a single email, not like one for each line, saying, hey, somebody reviewed your code. Go and look and see at the comments that they made. This is really good to even just try out and practice. You'll have an opportunity to sort of do that in class activities, hopefully, and something that you and your group can try out and mess around. Once that's done, you can really focus in now on those quality aspects. So we've started our review, and now we can start to ask these questions. I often find that people are a bit hesitant when it comes to leaving comments, because comments can feel really mean or critical of our teammates, of our friends, and that's not really what we're trying to do. We're trying to maintain a standard, right? So when we're doing our code reviews, we can really focus in on things like these questions. So rather than saying you did this wrong, or I don't like how you did this, we just ask questions like, what does your code do in case X? And allow the person an opportunity to comment back and respond, right? Maybe they thought of it, maybe they didn't. But as long as we sort of approach it from more of a curiosity standpoint, rather than a, I think you did this wrong standpoint, the conversation flows a lot more naturally and people get less offended, right? So it's always really good to be able to say, hey, did you check the project guidelines? It says X. Or according to Lauren's project guidelines, we can't have Y in this file, or whatever it might be, right? We're not blaming it. You can blame me. You don't want to blame your teammates because everybody's learning and trying to figure this out together. Once you've sort of done that, we can make sure that tests were added. If new code was added, tests are added. And we want to make sure that they're passing. And in step 4, I talk more about this. You really should try to check out the branch that's trying to be merged in. So you go to your own local machine and you type git checkout and then the name of the branch, and you can get your own local copy of the branch and you can try to run it. And it should work. It should work without you having to do anything. You should be able to put any changes you've been working on away, pull down a copy of their branch, push run, and the test should run. You can go and check through the GUI and make sure it looks the way it should, right? There's lots of sort of tests that you can do if you pull down your friend's branch before they try to merge it into the main line. Once you're all done, you can submit your review. Like I said, it will bundle all those comments up. And make sure at the end of it, you're writing something actionable, right? So approve, if you're giving your approval, you can say approve, right? Or you can request changes saying, I need you to change X, Y, and Z, or whatever it might be. As a team, you guys can decide, do you want only one approval on each merge request before it gets merged in? Would you rather that a minimum of 2 team members agree and approve it? Again, different teams have different requirements here. There are some companies that have like lead reviewers and then helper reviewers, and so the helper reviewers can give lots of feedback, but it really doesn't make, until the lead reviewer gives their okay, you're not able to merge it in. Now with GitLab, again, we can't stop you from merging it in without those approvals. So this does come down to sort of standards with your team, documenting those standards, and then being honest with your teammates and sticking with it. So some discussions can happen there for you and your teammates. Once you're done all of this, you click approve, you merge it in, and then most likely you should delete your branch. Like I said, we're not letting our branches live for very long, so you should delete your source branch. And if any labels need updating or milestones, if something got finished early or if something's not going to get finished, this is sort of our opportunity to take a quick breather and say, okay, what sort of administrative overhead needs to happen to make sure that our GitLab is representative of where our project state actually is right now. There's like geese outside my window. Okay, let's take a quick look at the sample workflow here. So imagine for a second that we have a main line that has some code on it, and we're ready to start working on a feature. We're going to create a branch, and we're going to switch over to that branch so that we're in our brand new feature branch. And here's where we make our changes. So we go from creating a branch to making our changes. Making changes literally is writing the code for the project. We make sure that it works. Making sure it works might mean writing our tests and running our tests and maybe clicking stuff manually and whatever that might mean for the piece of code you're working on. Once you've confirmed that the piece of code you're working on works, you can stage and commit it. Make sure you have a good message. Once all of that feels good, if we take that atomic commit sort of process, we push the branch remotely. If there are more changes that we want to make, we do this process again and we loop. Okay, we just keep iterating. Make a change, make sure it works, commit our work, push it up, go again. And this will ensure that every change we make, we know works. If a change gets made and breaks stuff, we know it's the newest change, not something from previous, because we've been very diligent in our commits and messaging. Okay, once you've made all the changes, so if there's no more relevant changes to make and we can't do this line anymore, we instead need to go this way because we're ready to merge back into our main line or into our dev environment. It just sort of depends on what you and your team decide. So at this point in time, you're going to pull down the mainline or dev, whatever it is you're planning to merge into. You're going to pull down and merge that branch into your local branch. We do this to ensure that if there are conflicts, we're dealing with them on our local branch instead of dealing with them on the main currently working space. If there were conflicts, fix them. This might mean writing new code, changing code, adapting code, whatever it might be. We need to make some changes that will fix all of the conflicts. Whoops. And what do we do after we do that? We have to come back and confirm that the code works. If we fix conflicts, we have to come back, confirm it works, commit the changes for our fixed conflicts, what we changed and why, push it remotely, and then we can go back over here. And again, notice that we are pulling and merging again. So after you fix a conflict and you've gone back to confirming it works, committing and pushing, you don't just pick up where you left off. Instead, you come back here and you pull and merge again, and you ask yourself again, were there conflicts? Because depending on how long this step took you to do, there could be new conflicts, there could be new merge problems, right? But ideally there isn't. Ideally you do your pull and your merge and you make sure that your code actually works. Yes, our code works. We're in a state that everything is working as it should be. Now is when we make a merge request on GitLab. Right, once your team has taken a look at that merge request, does your team recommend any changes? If they do, follow that arrow all the way back. You've got to make those changes. You've got to confirm it works. You've got to do your commit again, your pushes again. You have to do the pull and merge again. This process, like for my friend who it took 23 reviews, can take a long time. And if it's going to take a long time, more changes might be making their way into code, into the main line while you're doing this, right? So we're going to keep following this sort of workflow all the way until we get our approval from our teammates. Once we have our approval, we can merge our code in, and then everybody else can pull down those changes. Cool, that's great, and a great place for us to start. But in here, there was a lot of like manual confirm code works, right? There was a lot of this like pull down the branch. The reviewers are going to have to pull down the branch. We have to run all of the tests. Like there was a lot of manual labor. So in the new age world now we have this thing called CI, which is continuous integration. And effectively what it is it allows us to automatically run any test that we've written every single time we push code to the repo. So when you push code up, tests run. These tests can be things from like style changes all the way to actual bugs and like testing of functionality. So we can test both automatically. And basically every time you make a push or a merge request up to your repository, CI kicks off. It runs these tests. Pardon me. It can flag problems before your code gets merged in. It depends if it's supposed to run on merge request or if it runs on push or whatever. That's all customizable. And then in your GitLab repo, you'll see pass or fail checks, and there are error logs there, and it will tell you what you're passing and what you're failing. So if you accidentally miss a step, CI would allow us to check for those things. We can catch bugs early. It allows us to build confidence in our code base, and it makes sure that we're keeping main in a stable state. Now the thing is, we're not going to see any of this in this term. This is stuff that comes in software engineering too, because it involves other software, other systems, writing customizable configuration files. There's lots more to do around this, but it is kind of cool to see where our manual tests can sort of be offloaded and be turned into something that's really cool and happens all the time. All right, so at this point in time, you should be taking some time to explore the required readings and the linked video resources on the different branching strategies. It's important that you take a minute to ask yourself what strategies seem practical or effective, which ones don't really make sense to you, and how do they kind of align with your current working strategy. Now, it's really easy to sort of ignore some of these required readings and videos, but asking yourself these 3 questions may really save you if on a test you're asked to compare and contrast something from the required readings, like different branching strategies. So I recommend actually pausing and reflecting and doing those things. Once each of your teammates has had an opportunity to do this, you can sort of use these reflections to start to shape a branching workflow for you and your teammates, right? Taking this time to reflect and understand sort of what would work for you and understanding why that would work for you will allow you and your teammates to sort of communicate more effectively and figure out what will be the best for all of you. So take a minute to do that before you continue on with the next videos, and hopefully you will sort of reach a consensus with your team that allows you to have a very strong, stable workflow going forward. Awesome. Thank you, and I'll see you in the next video. Bye, everyone.